And what is H? Column vector. Well, you multiply all the multiplied matrix with column vector, you got a column vector. It's n by n, not n by 1. Okay. Alright. So everyone happy with this? Everybody happy with this? So if I have this now, so the optimal edge, so the H star, that is the argument of FH here. So remember, I have to minimize this mean square error. I minimize this thing here is when H make this derivative equal to 0. Right? Not the derivative, but the gradient equal to 0. So that means, let this thing here, then that derivative here equal to 0, or I have minus 2p plus 2 times RH equal to 0, or H optimal here equal to R minus 1p. So this is okay. Right? So that is the solution of this optimization. Now one thing I ignore is the setting this derivative. You know that to make this thing to minimize, what have to satisfy? First, this thing has to be equal to 0, and what else? The second derivative has to be positive with that. The thing ignore here, this R here, I don't get into detail, but this thing here, you can treat all the way like a positive number, not negative number. Because this matrix is so-called duplicate matrix, all the eigenvalue are non-negative. Okay. On the other hand, if you think about this function is always like this parabola. Right? And what you do here is you find a point where the derivative equals to 0. But you know that the function always move up, right? It's never like this system. Don't let it get trouble. Okay? So now let's think for a moment. There is a key formula, and the A satisfying this is called the winner filter. Winner filter. Very famous filter. Winner is a very famous mathematician and in MIT, and he derived this filter then after him. Okay. The filter here is that it's optimal that satisfies this. So now we go back to it. Well, so how can I find the winner filter? You ask yourself the question, what information do I need? What information do I need to be able to derive the winner filter? Right? So that I ask you, what do you need to find out the winner filter? You need to know R, and you need to know P. That's all. That's all you need to know, and after you have that, then you can get the filter that is optimal in mean square error. Right? That thing. So let's put the winner filter into practice. Okay. Example here. Example here is called the linear predictor. Alright? If you learn this thing well, you can use that to predict the stock market, the VN index tomorrow. Right? And if you get rich, you should pay me back something. Okay? So when you use winner filter to predict the stock market, and we want to ask ourselves, what information do we need? Okay? So, thinking about this, here in the stock market, it's a random variable, and every day I got some number, right? I got the price index, the VN index of instant N. So I want to predict this. Now what I have at my hand now is thing in the past. I have a thing in the past, right? Because at this instance, Let's say I'm doing today. So I have a stock market of today, yesterday, so on. And I want to predict what the price will do tomorrow. Right? When I know that price, I know whether I should sell or buy my stock. I can make money. Or I can, or maybe I predict the weather. I say, today temperature, yesterday, so on. I can predict the weather tomorrow. The predictor I have is a very simple predictor. The simple predictor I have now is I put a cell coefficient here. Maybe I take those numbers. So I take this number and I weigh them and multiply them with some constant. Right? Multiply them with some constant here. And I put them sum them up. And that is my predictor. So in other words, I'm going to take x of n equal to summation in k go from 1 to, let's say, n of x and of h of k, x of n minus k. K from 1, 2, 3 to n. So that means I use x of n minus 1, x n minus 2, x n minus n. Right? I use the linear combination of the thing I know in the past, and I want to predict this. So the input is this, and the output is this. Alright? With me. So this thing here is, this plays the role of the output. Now, in parallel, I know the x. I know that, So someone sitting up there maybe know that what the next price will be. This thing I do here. And that is the desired output. So to do that, I need to apply using the window filter. I want to do the prediction. Maybe I'm not correct today, but I have this filter and it keeps running. Every day I got something. So every day I make an error. That error now is equal to x, the actual value, minus the predictor I have. So now every day I make an error. And now the filter I want to have is, now maybe I make some mistake today, but on average, I'm optimal. Can you see that, right? I want to minimize this thing here in the mean square error at the mean. Okay, so to design that filter, what do I need? I need to have, for that, to design that filter in the optimal sense, we need to have this thing. We need to have this P, the P and the R. So the P and the R, okay, to find the optimal linear predictor of, it is a window filter with, what we need to have the P and the R. And what is the P? The P is, the xn here is simply, in our case, xn is this, is the vector xn. Right? It contains everything from n minus 1 to n minus n, to n. So I have this vector. And what I need here is I need to have, that is the design and time with this. So what I would need here is the P is all the gamma of x and itself. Right? X and x, because gamma is at the distance of 1. Okay, put the k here.